Okay, guys, the second part to simplifying or just discussing rational expressions and rational equations. So last week we talked about how you have to factor, you have to simplify, cross out things. You can only cross out factors, not terms. And then so today, what I'm going to add to that is we are going to talk about setting extreme. There's lots of different words they use. So they use the words restrictions, excluded values, and extraneous solutions. Oh boy, no, I'm not gonna let me write it. Sorry, guys. So extraneous solutions. All three of those things are asking for the exact same thing. But the idea, so these four examples I have right here, for the most part, are already factored to the best of their ability. So this is simplified as it's possibly going to get. So as you know, hopefully you've done it in your calculator before, you understand that anytime there's a zero on the bottom of a fraction, it is done. You cannot do it. If you plug it in your calculator, it gives you an error. It doesn't give you an answer. I know with my math one guys, I make them push like 0 divided by 2 because that gives me 0. But 2 divided by 0 gives you an error because you can't have a 0 in the bottom of the fraction. So no zeros in the denominator. And the way I think about that is a 0 looks a lot like a bomb. So if there's a bomb in the basement, are you getting to it before it blows everything up? Probably not. So if there's a 0 in the bottom, the whole thing's a wash. You can't discuss it. You can't use it anymore. So no zeros in the denominator. No zeros in the basement. So if we're looking at our first one, what number? So mathematically, you would set this equal to 0. So what can x not equal? And in this case, your restriction or excluded value or extraneous solution would be 0. So it could not, any value can be x. So I could have 5 over 1, 5 over 2, 5 over negative 1, 5 over negative 457. But as soon as you use an x value of 0, this fraction and this rational expression is done. Can't do it. So looking at B, so we're only working on the denominator. Now, there's an x at the top and an x at the bottom. When we're talking no zeros in the denominator, and I mentioned quickly, if you type this in your calculator, what do you get? Do you still get that error message, or do we actually get 0? You actually get 0. And 0 is a number. It is a place on the coordinate plane or a coordinate grid. 0 is allowed as long as it's not in the basement. So 0 is allowed in the numerator. So we don't set restrictions or excluded values in the numerator. So the factors at the top have nothing to do with your no touch hands off numbers. You only look in the denominator. So I have x minus 3, set that equal to 0, solve for x, which is going to move that 3 over. So that's going to give me an extraneous solution or a restriction or excluded value of a positive 3. All right, looking at C. We don't touch the numerator if we're discussing restrictions or excluded values. Now, the denominator. So I have x squared plus 2 in the denominator. We're going to set it equal to 0. We're going to solve it. So that's going to give me an x squared equals negative 2. Well, this problem is no good. You can't square anything and get a negative number out. So all numbers will work because no number will go in that place and leave a 0. So there's no restricted values here. Now this is not a blanket rule because it's an x squared. Because let's go down here for a second. So if it was x squared minus 2 in the basement or in the denominator, I could move that x squared equals 2. Let's choose a better number for conversation's purposes. Sorry. Let's do x squared minus 4. So I move that, it becomes a positive 4. I take the square root. X equals plus minus 4, because remember, every time you take the square root of something, you have a positive and a negative answer. So if the denominator had been x squared minus 4, the extraneous solutions or excluded values or restrictions could be a positive 4 and a negative 4. All right, so going back up here, so this would have looked like a trinomial, like a quadratic on top of a quadratic trinomial. We would have factored it down to this point. In this case, nothing can cross out. Now, here's your other big note to self. Find restrictions or excluded values. Define exclusions before you simplify. So before you cross things out, you got to find your exclusion. So in this case, we're going to do it twice. I need to know if I had x plus 5 set it equal to 0. Move that 5. So x cannot equal a negative 5. I have that x minus 1. Set it equal to 0. Move that 1. That means x cannot equal a positive 1. So the excluded values or restrictions would be negative 5 and positive 1. Now, if you're really good at using your calculator and you were to plug this equation in your y1, now, I would highly recommend being careful with your parentheses and orders of operations. But if you hit alpha y equals, there should pop up a place where you can put in an actual fraction. And if you can put in an actual fraction and you put that guy in there appropriately in your calculator, you should see that when x is negative 5, it should say error or no solution to the right. And when x is 1, your y value again is going to be an error or no solution there as well, because again, those two numbers are going to make the basement have a 0. And if this factor turns into a 0 when I multiply it through, it'll cancel out this one. If this factor turns into a 0 when I multiplied through, it would cancel out the bottom altogether. All right, so look at number 9, or page 9 in our plethora of rationals. Then this first example, again, is still already factored out for us. So nothing crosses out at this point. So we're just going to take our basement, guys. So 3x is one of the factors, set it equal to 0. And then 2x minus 1 and set it equal to 0. Pause your video, figure out what the two restricted values are. So we're going to add both sides. 3, so x cannot equal 0. And then we're going to add 1, 2x equals 1, divide by 2. X cannot equal 1/2. So our restricted values are going to be 0 and 1/2. So those are the two numbers that would make the basement a 0, which is the problem. You don't worry about the numerator because numerators can have a 0 at the top. So it's fair game to all numbers up there. Now, looking at F, your first step, always, and I said it last week, always for rationals, factor. So factor first, then start worrying about your restrictions, then simplify. So factor, restrictions, simplify. Factor, excluded values, simplify. So again, factor, excluded values, simplify. So looking at F, the top, this is your trinomial. This is where you would use your big star maybe, or maybe this one you could do in your head. So you have a negative 4, your B value is a negative 3, you have 1x and 1x. Are there anything that I can multiply 4 together to get 4 that will give me a 3, and I need a negative 4 and a negative 3. So how about a 4 and a 1, because 4 times 1 gives me 4, and 4 minus 1 gives me 3. I need that 3 to be negative, so it's going to be a negative 4. That's going to be a negative 4. So that means we're going to have x minus 4 and x plus 1, and that's taking care of that guy. So he's gone. Now that's the upstairs. Now at the bottom, I have x squared minus 2x. It's a binomial, so you can't big star. So my first thing I would always think is GCF. Do they have anything in common? There's 2 x's here, there's 1 x here, so that means I can actually factor out an x. That's going to be x minus 2 on the inside. So we have factored that guy. Now we want to work on restrictions. Do we need to do anything at the top? No, because remember, this works. We can use this. Nothing crosses out because nothing matches as full factors. This x does not get rid of this x. This would only get rid of an x minus 4 in the denominator. This would only get rid of an x plus 1 in the denominator. Only an x by itself at the top could go away because this is in the denominator. And only a full x minus 2 in the top could cross out. So now we're just going to set x equal to 0 and x minus 2 equals 0. Pause your video. Find out what your restricted values are. All right, so the first one was pretty simple. X can't equal 0. So x cannot equal 2. So your restricted value for this guy is going to be 0 and positive 2. So 0 and positive 2 are the excluded values, extraneous solutions, or restricted values. All right, so we're looking at the letter G. So I need to factor the guy at the top. Now, x squared plus 4. If that was a minus, then I could do perfect squares. I could square root the x squared and square root the 4, or differences of squares, I'm sorry. But this is a plus. So that means you're locked in there. There's no GCF. There's no big star option. There's nothing you can do with it. So it is factored to its simplest form at the top. So if we're looking at the bottom, we have a positive 6, a negative 5, a 1x, and a 1x. What do I multiply together to get 6? That could give me a negative 5. I need a positive 6 and a negative 5. So that means anything that multiplies 6 and 1, they both have to be positive, or the 3 and the 2 have to be positive to give me that 6. So it's going to be negative, I'm sorry. Ooh. We're going to go with a negative 3 and a negative 5, because that would give me, sorry, negative 3, negative 2, would add to give me a negative 5, but multiply to give me a positive 6. So that means the bottom, so here's G, we've got x minus 3 and x minus 2 on the bottom, and we've taken care of that trinomial. So factor first, check, we've done that. Now we're going to set our restrictions or excluded values, or tell the teacher, the worksheet, the test, what numbers cannot be used. So we're looking at the table in the calculator. Beside those x values, you would see the word error. All right, so pause your screen. Tell me what the restricted values are. All right, so we have x minus 3 equals 0. Solve it. Should be x cannot equal to 3. And then x minus 2 equals 0. Move it. So x cannot equal to 2. So our excluded values are going to be a positive 3 and a positive 2. Alrighty. The last but not least. Now, this guy at the top, x squared, I could take the square root of x squared and get an x, and the square root of y squared if this was a minus in the middle. But because it's a plus, both of these are perfect squares, but this is sum of perfect squares. And we can't do sum, so we can only do differences of perfect squares. We'll look at there at the bottom. So I can take the square root of this guy and the square root of this guy, and I know I get an x because x times x gives me x squared, and y times y gives me y squared. So x and x, y and y, and I get a plus and I get a minus. So this way I can't tell what your excluded, x cannot equal y, or x cannot equal negative y. So x cannot equal a negative y, because if I was to solve this guy, put it equal to 0 and find out what can x not be, it can't be an x cannot be a negative value of the y, and then x can also not be a positive value y, because when I move this over, so it can't be, x can't be equal to y, and it can't be equal to negative y. So those would be your restricted values. You shouldn't run into any of those with double variables in that case on your IXLs or anything crazy, but it's a good conversation. Ultimately, the concepts are the same. It's just thinking outside the box and making sure you're applying them. All right. Make sure I'm not running into your problems. All right. So these are super simple. Here's what I'd like you to do. I want you to pause the video and go through D, E, and F and tell me all my excluded values. So just the first 3, and then tell me your excluded values and come back and talk to me. All right, so the first one, we're going to take denominator only, because numerator doesn't matter. Numerator does not matter because it can have a 0 at the top. Now, I do want to call out, this is a negative x in the front. That's a mess. You never want to leave anything like that. So we're going to factor out a 1, which is going to give me an x plus 3 on the top. So we just fixed that guy. Because when you're factoring and simplifying and doing all the things, you never want x to be negative. And ideally, you would like x to have a 1 in front of it to make it easiest. That's where you should be thinking GCF. But so excluded values. So we're going to do our x plus 3 equals 0. So our restricted value is a negative 3 because x cannot equal negative 3. Now, if I was to simplify this all the way through, those guys would go away. And our answer would be, we're left with a negative 1. Beautiful. All right, looking at E. Now, restricted values are what you were doing during your time. So 4, can 4 ever equal 0 just like that? No. My suggestion is still to make it a habit to write that, though. Because if that was a 4x, you'll write it off and not do it. And if it was 4x, then that does matter. That means x just can't equal to 0. And then x plus 2 equals 0. So move that 2. So x cannot equal a negative 2 in this problem. Now, if we're talking about solving it, maybe pause it and see what you would cross out to simplify it. All right, these guys match. These 4's can't cross out because this is attached to that x with a minus. So your answer for this guy, once you've simplified it all the way through, is x minus 4 over 4. So that's our simplified answer for E. Yeah, simplified. And then our restricted value is -2. So you should have already worked on restricted values for F. So F, I have x plus 1, that'll equal to 0, solve it. So my list is going to be a -1, x plus 2, set it equal to 0, solve it. So x can't equal a -2, and then x minus 3, set it equal to 0, and solve it. So x cannot equal a +3. So that's my restricted values for this equation. Pause this bad boy and cross out what you can cross out and tell me what the simplified version is. These guys match. These guys match. So I'm left with x minus 1 over x plus 1. Now you can't cross out those 1's or those x's because they're both attached by addition or subtraction. So those guys are untouchable. All right, so G, again, factor first. This goes beautiful at the top, but the top doesn't matter as far as our restricted values. This, as far as just discussing your restricted values, this would work out for you either way. So I could set it equal to 0, which is going to give me -x equals -3 divided by -1. So x is going to be equal to 3, and then x minus 2 equals 0. If x is equal to a +2, we have a problem. So our restricted values would be a +3 and a +2. And the order in which you write those, no big deal. Just make sure you put squiggles on the outside, not parentheses, because that means there's a list. Now, as far as simplifying this guy, we have that -x there. We're going to take a -1 out. Now we can boogie with this guy. Pause your screen, cross out what you can, and come out with the final answer for me. All right, this guy goes away. This guy goes away. I'm left with an x plus 4 on the top. I'm left with a -1 and an x minus 2 on the bottom. So x plus 4 is definitely on the top. That -1, they're probably going to push it on through and give it a -x plus 2 as your final answer. If you were to write -1 times x minus 2 with the parentheses on the bottom, I would still consider that you understanding the concepts. All right, so looking at H, you should have already set your restrictions. Maybe, oh, I'm so sorry. I definitely told you to do D, E, and F. Pause your video, take a minute, set the restrictions, and then also go ahead and try to go ahead and simplify this bad boy. He's already factored for you for the most part. There's a couple messy guys in the numerator you want to pay close attention to, but otherwise, go ahead and factor, simplify, and set restrictions for these guys for me. All right, restrictions. So we're only doing the denominator because that's the only place x can't equal 0. So our restrictions are going to be 2 and a -3. And that's because these guys are the bottoms. Now we have a mess. X minus 1 is fine. We're good. This is a -x again. We can't have a -x. So we're going to pull out a -1. Make that an x. Let's make that 2 negative now because we need it to end as a +2 when we distribute it back through. So we had to fix this guy. And again, you have another -x here. So let's take out a -1 again. X plus 3. Because you don't want to leave your x's negative in factoring, for simplifying, solving, anything we do next. Now we can get to start crossing stuff out. So I have an x minus 2, an x minus 2, an x plus 3, an x plus 3. Now I have nothing left in the denominator, so we know that there's going to be nothing on the bottom. I have an x minus 1. So let's see if I can write this out so you can see it all. X minus 1 times a -1 times a -1. But -1 times -1 is a +1. So at that rate, x minus 1 is times a +1. So our answer is just simply x minus 1 once we've simplified it all the way down. All right, so some more practice on simplifying and factoring. And then also our added today is setting your restrictions, excluded values, or restricted values, extraneous solutions.